In this video, we're going to look at section 10.2, ratios and their applications. Okay, so here we define what a ratio is, a multiplicative comparison of two quantities. Okay, we compare the quantities multiplicatively by division. We often use a fraction, but then we also show them two other ways that we could represent this, using a colon, 6 miles to 3 miles, or A to B language, 6 miles to 3 miles. Other language we'll use that you'll see is it could be 6 miles for every 3 miles. That's other terminology that comes up. Something important that we'll see throughout this section is whether it's a part-whole comparison or a part-part comparison. So I use the example, Kate is traveling 100 miles to visit Rick. So far she's traveled 40 miles. Okay, so the ratio of miles Kate has traveled to the total number of miles is 40 miles over 100 miles. And I talk a lot about the keywords here. So blank to blank, that's the A to B language that typically shows up in word problems, or A for every B. So the first number, miles Kate has traveled, is our numerator, and the bottom number is total number of miles. Okay, or we could say the ratio of miles Kate has traveled to the miles she needs to travel. Well, that would be 40 miles over 60 miles. And of course we can also reverse these. We could have the ratio of miles she needs to travel to the miles she's already traveled. That would be 60 over 40. And throughout this section we're going to have them write these in all of these different ways, using units, and also so the units will always match up in ratios, but we might in particular talk about this being miles traveled and this being total miles, okay, and using those as cues for unit analysis, kind of like we do with geometry, so we know how to set up our ratios when we're multiplying to solve proportions. Okay, so let's just take a look. Okay, so here there's a couple of problems like this: fraction language, colon language, A to B language, ratio of students who passed to students who failed. So I'm not going to read this whole thing, but 8 students passed for every 2 students that failed. Okay, so having them set these up, so passed is, I'm going to write 8 passed, 2 failed. Okay, and I want them to include the passed and the failed, again, just so when we solve later we know that which quantity is representing what. Okay, I do ask for them to write a simplified ratio, and then notice here it says ratio of students who failed to students who passed is 2 failed for every 8 that passed. Okay, and if we write these just as numbers, this is 4 to 1 or 4, and this is 1 to 4. Okay, and we really want them to see, just like with the broomsticks, that when you compare two quantities in the opposite direction, we get reciprocals. Okay, then you know, colon language and A to B language. Same idea, we want them to write the passed and failed, and then are they part to whole or part to part comparisons, explain. And in this case we have the passed and the failed. The total is the total number of students, so this is a part comparison. So the two parts, the passed students and the failed students, equal the total number of students. Okay. In this one we have 6 blue fish and 9 yellow fish. Okay, write the ratios, then write a simplified ratio. So blue fish to total fish and yellow fish to total fish. Okay, so just something that I'm going to bring up throughout this because I really struggled with writing this. In this case there were 6 blue fish and 9 yellow fish, so the total number of fish is 15 fish. Okay, so blue fish, we'll say 6 blue to 15 total. Okay, and if you don't have a student that writes 6 over 9, I'll give you $1. Okay, so they need to attend to all of these different descriptions. Okay, and here it would be the other way, 15 total over 6 blue. Okay. So the reason I want you to think about the total, we're going to see in the next couple of problems, if not the next one. Here we know that the total number of fish is 15 fish. Okay, but it could be the case that in Cedric's fish tank there were 6 blue fish for every 9 yellow fish. Okay, and that would mean that 6 blue to either color or both colors would be the ratio, but we wouldn't know the total number of fish is 15. Okay, here we actually do. Okay, and this is a subtle distinction that when you're labeling these, you want to be careful of the terminology you use. So let's look at the next one, which I believe has this idea. Okay, so Maureen went to the aquarium, giant fish tank. It only had blue and orange fish. A sign on the tank said there were 2 blue fish for every 3 orange fish. Okay, so blue fish to orange fish. So we're going to put 2 blue. Okay, that's not how you spell blue. 2 blue over 3 orange. Okay, and here we have orange fish to blue fish, and again the units are the same, they're all fish, but I'm putting down that the color that tells us how we are comparing these. So even though they're different, they're still ratios. Okay. Now, again, this is where I had trouble wording things, and I asked a bunch of people, and everybody had a different idea. Ratio of blue fish to both colors of fish. Okay, so I didn't want to say blue fish to total fish because there's not 5 fish in this tank. Okay, this is the ratio of fish. So some people said, say, both colors of fish. Some people said either color fish. Okay, so by both colors, I didn't mean, you know, the fish were both blue and orange. Okay, so you could put either color, but basically you want them to see this is both or either type of fish combined. Okay, if you can think of a better way to say that, please let me know. So we have 2 blue, and we'll say 5. Now I want to write either rather than both. Okay, as long as you're consistent. And here, orange, 3 blue to 5 of either color. Okay, so notice these are part-part comparisons, and these are part to whole comparisons. Okay, and then you're going to be asked, or they're going to be asked to solve problems with these. Okay, so again, here we have, this is a double number line. I was very careful how I labeled these. This says ratio of blue fish to both colors of fish, and this is total number of fish. So in this problem, we're given that she asked the tour guide, well, how many fish are in this tank? Now we know the total. The total number of fish is 90. Okay, so you want to make sure that you label these carefully, just like you would with variables. You don't want to just write, you know, blue. Okay, or blue/orange. You want to be particular about how you label these. Okay, so if you're at SCC, we bought these pieces of plastic that have double number lines on them that you can use Expo markers to dry erase. So you can use those for these problems if you'd like. Okay, so we know that 2/5 of the fish are blue. Okay, so we can cut this into 5 equal pieces. Okay, this is 1/5, this is 2/5, etc. Okay, so now we want them to see that there's a correspondence between 2/5 and 2/5 of 90. So just like we cut from 0 to 1 in 5 equal pieces, and then we took 2 copies of it, we want to do the same thing with the total number of fish, okay, which is 90. So we'll take the 90, divide it by 5, and that's 18. So we'll make the 5 corresponding, or the tick marks that correspond, okay, and each copy of 1/5 is 18. So now 1/5 would be 18. Now we have 2 copies, 36, 3, 4, etc. Okay. So for the symbolic representation, what are they really doing here? Well, we have 2 blue over 5 both colors times 90 total fish. And I'm going to put here the total are referring to both colors. Okay. So we divided the 90 by 5. So we want them to get used to just multiplying by this ratio, but we want them, rather than, you know, writing this as 90 divided by 5 times 2, okay, we want them to start to see that this is 2/5 of the 90 is equivalent to partitioning into 5 equal pieces. So there's the divide by 5, and then we took 2 copies of those, which gives us the 36. Okay, so use the units to help them see. Okay, help them see that these cancel. Okay, and that when we multiply these two, I'm sorry, what was this again? 18. So 90 divided by 5 is 18. 18 times 2 is 36, and we get 36 blue total. Okay, so this is the symbolic representation. Here I asked the same question. I don't really know why. Number of blue fish in the tank is 36 blue. Okay, and then corresponding proportional statement. So since it is proportional reasoning, even though we're not cross multiplying, I wanted to include the statements in here to get them to connect this idea. So remember, a proportion is a statement that 2 ratios are equal. And our ratio is that 2 to 5, or ratios, 2, 5, this is blue, this is both, is equal to 36 blue total over 90 total. So this is both, and this is blue, okay, and these are the total in the tank, okay. And it's nice to set this up also without the units so they could see the quantities, okay, and have them see equivalent fractions. You can connect this idea. 5 times 18 is 90, 2 times 18 is 36. Okay, here we do the same thing with the orange fish. Okay, and this is the same idea, except I think here we have part-to-part comparisons. Okay, so we have Smarties to Gobstoppers, so we don't look at the total when we're looking here. Okay, right, so we're not looking at the total number of candies, we're just looking at the comparisons. So it says Amy will give Jen 4 Gobstoppers for every 7 Smarties. So the units are candies, the specific type are Gobstoppers and Smarties. Okay, so Smarties to Gobstoppers is 7 Smarties to 4 Gobstoppers. And then, of course, we'd write it the reciprocal for the Gobstoppers to Smarties. Okay, and then we need to figure out if Amy has 20 Gobstoppers, how many Smarties would Jen give to her? So the relationship from the previous slide was 4 Gobstoppers for 7 Smarties. So we can think of breaking these Gobstoppers into groups of 4. So we divide the 20 by 4. So there's going to be 5 groups of 4. Okay, so we want to partition this into 5 pieces. And each one of them is 4. So 4, 8, 16. Oh, I doubled there. I think I was getting all exponential. Let's go back. 4, 8, 12, 16, 20. Okay. And then we look, well, the Smarties, there's going to be 7 Smarties for every 4 Gobstoppers. So the 4 corresponds to 7. This is 14, 21, 28, and 35. Okay, so notice we divided by 4 and we multiplied by 7. Okay, and if we start with 20 Gobstoppers, okay, again, think of this as unit analysis. We want to divide by the 4 Gobstoppers, okay, to get the 5.